at the heart, if you're looking at the digestive, if you're looking at skeletal, whatever the case might be, it's this point. Everything is occurring. So, at this point where everything takes place, the exchange, we're going to see, okay, I've got my blood flowing through here. All right, I need to make sure, one thing that's very important, my oxygen moving, my glucose moving, my ions, my hormones, anything that could be considered a nutrient is moving. I need to make sure, for example, antibodies, which we've only mentioned a little bit, like we talked in the blood chapter, but we're going to get into that when we start talking about the immune chapter. Okay, anything that would be considered needed, this is where it's going to drop off to. It's going to drop off into my extracellular fluid. That means it's not going from the blood directly to the cell. It makes its drop off into the extracellular fluid. I need to make sure that anything from these tissues, that would be a waste, because that's what's going to happen. As those cells do their job, anything that's given off by that cell would be a waste. Wastes that are given off are toxic to the tissue. They have to be gotten rid of. So, once again, the wastes go into extracellular fluid. And then, all of a sudden, we have all these capillary beds that are in contact with the extracellular fluid. Is everybody following me? Okay. Water movement is important. Do you all remember osmosis? What is the definition of osmosis? It is the diffusion of water across a selectively permeable membrane from an area of high concentration to low. What's the definition of diffusion? Do what?
It said it's basically the same thing.
No. See, this is where I find something that is so important doesn't get taught. Okay? Osmosis. Write it down. Diffusion of water. That's it. Across the selectively permeable membrane from an area of high concentration to low. That is the only thing osmosis deals with. Diffusion. Movement of particles from an area of high concentration to low. What's the difference?
Particles in water. I said, is it particles in water?
Okay, so I've got particles that could be in the water. they usually talk about it in terms of hypotonic, hypertonic, isotonic. Do you remember those terms? All right. So, in terms of hypertonic, hypotonic, isotonic, which one do animal cells, us, need to live in for survival?
Isotonic.
We need to be in isotonic conditions because that means the same. So, if I think about a cell and my extracellular fluid that is around it, okay, think of this as the beaker because that's usually how they represent it, okay? This is my cell, and let's say, based on particles, it's at 0.7%. For this cell to stay alive, my extracellular fluid needs to be 0.7 also. Is everybody following me? That 0.7 would be based on the particles found in the fluid, i.e. the water. Okay? Now, let's think about a couple of situations. Think about these cells over here that are in my tissue, that are surrounded by extracellular fluid, that are in contact with my capillary bed, which will supply everything they need. Cells can do what they need, create their waste. What would happen if my cells, that percentage, went up or down? Let's go with up. I'm going to see, let's say that the cell went up to 1%, but out here in my extracellular fluid, I'm still at 0.7. Based upon movement of water, which is osmosis, the diffusion of water across a selectively permeable membrane, my plasma membrane of my cell, it needs to go from an area of high concentration to low. Now, these numbers are based on my particles. The movement of the water, is it higher in my extracellular fluid or in my cell?
So,
No. Why? Alex?
There's more stuff inside the cell, so there's less water.
Yes. And there's more water outside the cell than stuff. So the only way for my water to go is into this cell. Does everybody see how I got that? Does everybody trust me on this? You've got to know this. You have no choice. When you go into your programs. Your very first class you take is going to expect you to know this. Why did this happen?
Is that a hypo time?
This, well, depending on what you're looking at, okay, you would say that my fluid is hypo, okay, and it's hyper in my cell. Does that make sense? Hypo and hyper, depending on what you're looking at. Are you looking at the particles? Are you looking at the water amount? Yeah. Yeah. When I say you are going to need to know this, you are going to need to know this. Now, what that causes, Gabrielle, do you have a question?
So the percentage is, are you referring to the particles or the water?
Okay, so if we look at my particles, okay, what we're seeing is high, meaning hyper, in the cell, hypo in the extracellular fluid. If I'm looking at my water, it's hypo in the cell, hyper in the extracellular fluid. Is everybody following with me? This was a concept that should have been taught all the way back in general bio. And it definitely should have been taught in part 1. It's probably something I need to add to my little videos with the plasma membrane, but I'll do that later. Now, why does this become clinically significant? Why does this situation that I created right here become clinically significant? What is going to happen to the water flow, the water amount in the blood going in through those capillaries at that tissue level into the tissue extracellular fluid? What is going to happen? Is water going to move into my extracellular fluid, or is it going to move out of my extracellular fluid? It's going to move into, because the cells are going to be producing huge amounts of waste. Okay? This means extracellular fluid is going to get more water to try to get the cell back into balance. In situations where this does not balance out correctly. Huh? What? What was that? Interesting. Anybody know what it said? I heard something about tissue. This could, for example, result in situations of edema, and in cases where these tissues are not functioning correctly, can edema become a life-threatening problem? Yes.
When you have edema, why do they say reduce your salt intake?
What is one of the nutrients that comes in for the capillaries?
Sodium.
My salts. What is built up in my cell?
Sodium.
Particles, which could include salt, which is meaning this is keeping it higher, making more water come in, and if you reduce your salt intake, hopefully this number will drop, which will drop the water flow into those tissues and reduce the edema.